We are going to crystallize sulfanilamide. We have a sample of impure sulfanilamide here. Impure sulfanilamide. It's a white solid. It's made up of about 95% sulfanilamide, one of the first antibiotics, and about 5% acetanilide, which is acting as an impurity. And it's actually a good choice for impurity for this because you can make the acetanilide into the sulfanilamide. You can do a synthesis, multi-step synthesis. I've done it in previous years with my students. And so there is a possibility that when you get your final target molecule, you have some of the original impurity in there and you want to purify it. We're going to do that using the most common organic solvent for crystallizations, the ethanol. And ethanol is, of course, the alcohol in spirits and liquor, beer, wine, other things. And so we're going to be doing our crystallization in ethanol, the main active component of liquor. So we'll be using it as our mother liquor, as we learned. All right, so the first thing I'm going to do is take my 25 milliliter Erlenmeyers that I'm going to use and label both of them. I'm going to label one of them the ethanol solvent, and the other one's going to be for the solid, impure solid to start. I've labeled my beakers. I labeled this one ethanol and my initials and the date. It's good to label everything. Keep it straight. If there's other people in lab with you, you want to be able to say, hey, wait, that's mine. Let's not mix them up. And then this one's 95% sulfanilamide, which is the 5% acetanilide, initials and date. First thing I'm going to do to start off is I'm going to add what are called boiling stones to my crystallization flask where I'll put the ethanol in. So I'll show you where that is. It's right behind me. Up on the shelf here, we got some polytetrafluoral ethylene boiling stones. So what is that? PTFE, polytetrafluorine. Well, what that is it's a polymer of tetrafluoroethylene. Here's tetrafluoroethylene. When you polymerize this, it becomes a long polymer, and it's like you'd expect a hydrocarbon alkane, but it's not a hydrocarbon, it's a fluorocarbon. So no hydrogens, fluorines on all the carbons. And this big long chain molecule, this polymer, was discovered accidentally in a DuPont lab. When they discovered it, they found it was resistant to acids, bases, oxidizers, reducers, and they're like, wow, this thing's probably got some function to it. And then they got more and more popular, and now you've seen it. It is Teflon. This is Teflon, so like your Teflon pans or Teflon tape for pipes and things. And they use Teflon inside of pieces of equipment they put inside your body because it's very resistant and it doesn't cause much of an immune response in the body. So that's our Teflon. So this here, these little pieces of white plastic are Teflon. So I'm going to put a couple of those inside of my crystallization solvent flask. So let me get a couple out. There we go. Not too many because it's just going to be a pretty small amount of solvent I'm using here. So there it is. I've got some Teflon boiling stones inside of my ethanol flask. The purpose of those is to cause little bubbles to occur while I'm boiling this. So I want to boil this gently. And while I boil it, it could cause large bubbles, gas bubbles within the solvent to form, and when a large bubble forms, it can bump out. We call it bumping when it like kind of splashes out. You don't want that to happen. So these boiling stones, or another term for them is boil easers, they ease the boiling. What they do is they allow the solvent to form little tiny bubbles on the surface of those boiling stones, you'll see shortly. And then it's releasing little tiny bubbles, which is much safer than if without that you might get a big bubble that bursts and splashes out of the container. Okay, so next let's add ethanol to this. So let's go find the ethanol. Where do we keep the ethanol? We keep it, like we said last time, in the flammable cabinet. because ethanol is flammable. Come on in here, we got our ethanol. And the ethanol is denatured ethanol. So that means, like I said before, it's got usually isopropyl alcohol or methanol added to it. This way you don't have to pay taxes on it like it's a ethanol you can drink. And then people won't drink it too. So you don't want to drink this ethanol in lab. This is bad. It'll kill you faster than just an alcoholic drinking ethanol. Okay, so back over to our flask. So how should I add my ethanol to this? And I want to add about 15 milliliters. That should be enough for this crystallization. How do I do it? I could get the pipette and draw some up and see if it drips. It's not too drippy. Oh, it's looking good. I'm gonna spit it out anyway. So sometimes it starts dripping on you if you don't. Draw some up, dispense it, draw some up. Evaporatively cool that pass your pipette. Okay, I got a little bit of ethanol. So I'm gonna keep going until I get to 15 milliliters. This is gonna take a little while because this pipette only puts less than a milliliter at a time. So instead of doing that, why don't I just pour it in there? No, I don't want to do that. I think that's going to make a mess. So I'll use a funnel, short stem funnel here. Should I do that? The short stem funnel is kind of heavy for such a little flask. No, I'll tell you what I'll do. I'm going to do it right. I'm going to get a ring stand and a O-ring here. And I'm going to tighten this on here and hang the funnel from that. I'll show you. Okay, I've attached the O-ring to the ring stand. Now my funnel can sit up here, and I'll be able to pour the ethanol in there without too much of a mess. I want about 15 milliliters, so it's just approximate. So there's a line down here. That's the 15 milliliter line, if you see it. Yep, 15 milliliters. So let's see if I can do it. Pretty good. Just one little drop spilt. I could have been more fancy about it and had used a glass stir rod to help with the drippage, but I knew ethanol is pretty viscous. It doesn't drip too much, and I only have one hand to do it because I'm using my phone to film the other hand. Okay, so yeah, we're a little bit over 15 milliliters, but that's fine. We're going to use the excess to help wash the mother liquor off our crystals as we filter them. So now I want to take this ethanol flask with the boiling stones. I want to put it on my hot plate and get it heated up. And because I want it to be boiling gently for this crystallization, and it'll take a little while to boil. So what I'm doing is I'm starting the heating of this first before I weigh my sulfanilamide solid into this other flask. Okay, so let's turn this heater on. How do we do it? So right now it's off. It's in the off position. There's the heat knob that'll turn on the heat, and then there's a stir knob. We're not going to use the stir this time because we have boiling stones. If we wanted to stir this solution, we could add something called a stir bar. It's a little piece of magnet with Teflon coating on it. And then underneath this stir plate, I'll show you later, it has a magnet that'll spin and stir your solution. So for now though, we'll just turn the heat on. How do we do it? We just turn this dial until we see a green dot. So what does that green dot mean? The green dot means that whatever value I have this set to, it's not quite at that temperature, and it's heating to get there. So right now, I believe, yeah, this is supposed to be 100 degrees Celsius. So what it's saying is the hot plate is not at 100 degrees Celsius currently, and it's heating it to that point. Once it gets to 100, probably a little over 100, I bet once it's heated this to about 102 degrees Celsius, it'll stop heating because it's already past where it wants to be, and it'll let the hot plate just cool in the air, and then when the hot plate is cooled a little below 100, probably 98, 99, it turns back on and you see the green light turn on. So the green light tells you it's not quite at this temperature, it's heating up to that at this point. And when it turns off, it means it's past it and it's letting it cool. So it just kind of turns on and off to keep it around 100 degrees Celsius. So I'm gonna let that go. This is just a little warning light if you saw that coming on, just telling you now it's hot so you don't wanna touch it. Now I'm gonna walk over and fill up the crystallization flask with my impure sulfanilamide. I'm at this scale. I'm going to take my empty sulfanilamide, impure sulfanilamide crystallization flask, set it on the scale, and tare it. It's fluctuating a little bit, not too much. Maybe I'll hit tare one more time. Looks pretty good. Okay, now I'll add the impure sulfanilamide. So, how should I add this? Should I just take my micro spatula, scoop some out, and try to add it while it's in the... No, it'll probably spill. What about if I open up the top of the scale and I go from the top, just like three-pointer, bam. No, I don't want to do that. I'm going to make a mess in my scale. What I'll do is I'll always pull the flask out of the scale and add the solid to it that way. Let me set this, yeah, I remember how to do it. Let's set this up here. There we go. So I'm going to get a little bit of solid. I'm going to try, well, I'm aiming for about 0.3 grams. So I've added that, and I'll put this inside of the scale, and we'll see where we're at. Okay, we want 0.3 grams, and that much so far is only less than 0.1 grams, so it's about, so we got to go about 5 times as much. So I can now, I got a feel for how dense this solid is. I could try adding a little more at a time. Okay, I got another scoop. Another scoop. This solid is very fine. It's not very dense. It's very light. So it's, oh, I went over. I got 0.369. It's not too bad, but I'm gonna remove some because I feel like I want to get closer to 0.3. So what should I do? Should I take this out and put it right in the waste bottle? Nah, I know that this Erlenmeyer's flask is clean, my spatula is clean, and also that this is impure sulfanilamide. I'm putting it back into the impure sulfanilamide bottle. So it's not like I'm gonna make this, you know, that much more impure. It's fine. So I'm waste not, instead of being smart about it, I'm not just throwing it away without thinking it over first. So 0.336, I'm gonna take a little bit more out. And then whatever we get there, I'm gonna write that number down and record it. There we go. And when I'm done with my reagent, I do want to cap it right away, keep moisture out of it, keep anything from spilling in it. Okay, let's see. 0.3186. Okay, that's close enough for me. I'm going to record that into my notes and I'll give it to you in the Google Doc for this assignment. I've weighed out my sulfanilamide. I think I said the value wrong. It's a 0.3184 grams. So I've weighed that out. I came back to check on my heating ethanol and it's not boiling yet. So I went ahead and I turned up the temperature to 200. I'm not sure how accurate the degrees Celsius is for these values. And even if I got it, if I have it at 200, the hot plate's not at 200 right now. It might heat faster. I'm not 100% sure if it heats faster if I have it on 100 or 200 if it's below 100. But I'll just put it there and we'll wait for the ethanol to start boiling. Once it does, then I'm gonna use a pasteur pipette to pipette the boiling ethanol into my impure solid, and to try to add the minimal amount of hot solid to dissolve everything, not too much, but this one I'm gonna try to dissolve all of the solid. It works out well, and then I'll let it cool and crystallize. As I add the hot solvent to the impure solid, it'll instantly cool. If this solvent is boiling and I add it over here, it'll be cooling in this flask. So what I want to do is put this flask on the hot plate as well, so it can be heated while I'm adding the hot boiling ethanol. Do I though want to put this solid sample in the glass on the hot plate now when there's no solvent in it yet? I do not, because a solvent boiling in a flask really cools down the glass of the flask. The evaporative cooling is powerful. So I don't want to put my glass on the hot plate without any solvent, because the glass will get extremely hot and most likely then oxidize the solid and burn it up. So we don't want that. So we're gonna wait till this boils and I'll show you what I mean. I'm starting to see some bubbles off the boiling stones. See the little tiny bubbles. They'll help ease the boiling so I won't have it bump out of the flask and all over the place. We don't want that. Okay, we're getting there. It's got a nice bubble to it. If it gets a little too bubbly, I'm going to turn down the temp, which I'm actually going to do now. Turn it back to 100. I think this looks pretty good. So what I'll do initially is add some of this boiling ethanol to my impure solid off of the hot plate. I want to coat the bottom of the flask so that it has protection from a solvent in there. So here it goes. I draw some up, and I'm actually going to spit some out a little bit to really get this. I don't know how that works, but I think it's good to get the thing wet. It drips less. So I've got some ethanol in there, but I'm going to do a little bit more because this hot plate's pretty hot, and I want it to be good. Okay, so the ethanol I've added so far is already started cooling. It's not boiling. That's why I want to put it back on the hot plate, because I want to add the minimal amount of hot solvent. Got it in there, and I'll wait a little while until my crystallization flask on the here is actually boiling a little bit, and the actual impure solid acts as like boiling stones for it. And then I can swirl it around a little bit. It looks like I've still got quite a bit of solid left, so I'm going to add more ethanol. And with crystallizations, there's two things you got to be concerned with. One, that you don't add too much of the hot crystallization solvent. That'll lower your yield and you may not even get crystallization to occur. But also, you don't want to add the crystallization solvent too slowly, because if you're adding it like one drop at a time, then you might be adding drops at the same rate that it's evaporating out, and you're not really making a net difference in volume. I think actually I may have already hit it. Maybe it's easier to see on the black background. Let's do this. I think we're good. I think we've dissolved it. So I want this to cool slowly. If I put it on the countertop's pretty cold. It'll cool quickly. I want it to cool slower. I think it's nice to put it on a wood block. Wood, it cools a bit slower on. And I can also grab a beaker, set it over the top, and that will slow the cooling as well, because as this hot ethanol is evaporating out of the solution, it evaporatively cools. And if I put a beaker over it, it's trapping a lot of the ethanol gas, which slows down evaporation, slows down evaporative cooling. So if I leave this here, I should start to slowly see crystals soon. Over at the hot plate, my ethanol that's just boiling away, I can take it off the hot plate so that it won't evaporate as much. And now I can still use this. I'm going to use this during my filtration. And I turned off the hot plate. Another thing too, when you're done with the hot plate, it's a good practice to come over and unplug it, because if you unplug it, you know for sure it's off in case there's a malfunction. Okay, look at that. Pretty nice, huh? That was going for about 25 minutes. I let it cool. I just walked away and let it cool. At this point, we have to make a decision. Do we feel like our yield is enough where we just go ahead and filter this? Or do we think, you know what, that yield's a little low, and I want to agitate it, cool it, do something to have more crystals form, then filter. if I agitate it or cool it in an ice water bath or something and to have more crystals form, they will not be as pure because it'll crystallize quickly. The slower the crystallization, remember, the better the purity. So when I look at this, I think I'm gonna go with the just let it be. When I move it around, it'll probably start crystallizing a little more too. Yeah, this looks pretty good to me. So I'm just gonna filter it. I'm not gonna cool it in an ice water bath. I could, it'll increase the yield, but I'll lower the purity. I'm just gonna go with it as is. So now I have to set up my filtration.